So looking at the first question, we're dealing with tangent segments. A tangent segment is a segment that touches the circle only once. There is one tangent segment there. There is another one there. When they happen to meet outside of the circle, which is the case, they equal each other. I'm just going to say 3x plus 2 equals 2x plus 5, and then work it out from there. Once again, the algebra steps I'm not going to work. Some of them, I might even give you the number for the radius. I might come and say radius is 10. Just ignore it. Just one tangent equals the other tangent. Who cares about the radius? Just move on. The same idea is used in question number 2. I see 11.4 is a tangent. It's a little tangent. So this other one out here is also going to be 11.4. They're equal. I see that 7.7 is a tangent. So the other tangent there is 7.3. Right where the 7.3 is, I see the whole thing is 21.3. Part of it is 7.3. Subtract them. I want to get the other side is 14, and so is this one. Now, I'm asking you guys for perimeter. This whole side right here is 21.3. Right? It was given to begin with. This other side right here is 18.7. I added the two small numbers. This other side right here is going to be 25.4. I added those two numbers. Now add the sides for the polygon. That will be your answer. So again, I'm not going to do it all. I'm just setting it up. On the test, you're expecting one of each from here. Now, question number 3 might require a couple steps. I'm looking at a triangle where two sides are equal, right? I see a radius, the other side is radius. Two sides are equal, two angles are equal. One angle is 39. This other angle here is also 39. Then I also know that the angle made by a radius and a tangent, here's a radius, here's a tangent. An angle made by a radius and a tangent is 90. Part of it is 39. I'm thinking 90 minus 39, that's 51. So this angle is 51, and so is this one. Then to finish this, I'm going to look at a triangle. I'm looking at this triangle. If I add the three angles of the triangle, x plus 51 plus 51 is equal to 180, then I can solve for x. Giving you a number to begin with, 39, think what you can do with that number and then move on. Question number 4, this is what we saw this Monday. What's the length of part of the circle? The length of an arc? First, I look at how much of the circle I have. 135 out of 360. I'm going to multiply this by the length of the whole circle. Since the radius is 14, I'm going to say the entire length is 28 pi over 1. Because I went radius times 2. That's where the 28 comes from. Simplify your fractions, multiplied, and just move it from there. Any questions so far? No? Then we do have arcs. Let me do 3 questions here. Now we have some chords here. Now question number 5 are the easy questions. I see here that x is a radius, and I see that 19 is another radius. One radius equals another radius. So x equals 19. There's not much to work. The answer is there. Not only radius, but I might also use chords. As an example, I can say this part of the chord is y. Let's say this part of the chord is 10. The chord, you see the 90-degree symbol with a segment starting from the center. The chord gets cut in half. So for that one, I will say y equals 10. There's not much work to do. So I might use a chord, I might use a radius, but question number 5 is that simple. Question number 6 is not that difficult either. I see a radius there from the center all the way out. I also see a 33.4 in the center of the circle. So I mean 33.4 is the diameter. For me to find a radius from the diameter, divide that by 2. 33.4 divided by 2, that gives me 16.7. So I'm going to break this into 16.7 each. So I'm going to say one radius is 16.7. Because I went diameter divided by 2 is what gave me the radius. Now here, I'm going to think of the idea one radius equals another radius. So x plus 10.4 is equal to 16.7. Right? One radius equals the other radius. Now, question number 7, x is a radius, so that's fine, but I don't see another radius. I see 8.1, which is part of a radius, but not the whole radius. I see 15.3, which is part of a chord. Combine all three pieces, make a right triangle. I know two values. I can solve for the third one using Pythagorean theorem. My hypotenuse is the biggest side, which in this case is x. So on a squared plus b squared equals c squared, that's my c. I'm going to set this thing up as 8.1 squared plus 15.3 squared equals x squared. I'll have to use Pythagorean theorem because I'm dealing with a triangle. Now on the test, question number 5, you're going to have one of those. Question number 6, 2 of them. Question number 7, 1 of them. So kind of like one of each, except number 6, 2 of them. My last 2 examples is what we saw last week. Now looking at question number 8, I'm always going to start with 2 times the angle. And in this case, the angle is x, right? The corner. So I'm going to go 2 times x. That angle is on the circle, and it makes that arc. The angle makes the arc 110. So 2 times x equals 110. Just work it out from there. Looking at question number 9, my angle is 4x plus 7. So I'm going to go 2 times the angle. It's going to equal 2. Because the angle is outside of the circle, I have to subtract my 2 arcs. I see on the arcs, one of them is 125. The other one completes the circle. So for the bigger one, I'm thinking 360 minus 125. That's 235. Now that I have the 2 arcs, I'm going to subtract them. 235 minus 125 and work it out from there.
Where'd you get the 235?
360 minus 125. 235 is what completes the circle. And just work it out from there. On the test, you will have one of each.